So let's just take a look at things and get a sense of what there is and what might go wrong and how we can use the control system to diagnose it. So what we've done here is taken the whole control structure out of the heat pump, mounted it on a board. And I'm just going to flick this switch here right now, and I'll explain why in just a second, but it needs a little bit of a delay to make things happen. So the first thing I'd draw your attention to would be the black line right down the middle. And everything on the left-hand side of that black line over here is the higher voltage, or at least representative of the high voltage side. Everything on the right-hand side is representative of the low voltage side, or more accurately, kind of the control side of it. Now you'll notice that the light came on there, and there was a bit of a delay after I flicked the switch. That's quite normal. There's actually a built-in delay on these that helps to avoid, or does avoid really, the whole short cycling aspect of things, meaning the compressor coming on, coming off, coming on, coming off too frequently. We've actually got this control panel down here set so that it comes on a little bit more quickly in the test mode than it would even as the heat pump sits on the floor. So you'll see some of the things there that are factors. At any rate, again, drawing your attention to the low voltage side of the system on the right hand side. Now on our website you'll be able to look at a diagram of this and have all of the components identified, and I'd suggest maybe it's a good idea to do that and print it out, look at that while we're talking through the system and so on. Nonetheless, I'll talk through it here now just a little bit to identify things, and so you'll have a little bit of a sense of what goes on in here and what there all is, etc. Beginning right here is the transformer, and what's happening is that we're going to feed that transformer on the left hand side, which, if you're really electronically up with things, that would be the primary side, and we'd feed that 240 volts, or at least thereabouts. That would transform down and generate 24 volts on the right hand side, so that we're feeding everything, as I said, on the right hand side of that black line down the middle with 24 volts. Now we've cheated a little bit because we just didn't want to have a demo panel with 240 volts floating around on it. So this line coming across here is actually just directly feeding 24 volts over to that side. So we're not actually operating with the high voltage. But nonetheless, what's taking place then is that transformer is supplying 24 volts to everything on this right hand side of the line. And to jump into things a little bit more completely, there's in a sense the heart of the system. That's the control board, and it takes all the signals and determines what should happen with them and whether power should be sent to the compressor, how it should be sent to the fan, and indeed to some degree whether we want to trigger the relay here, which actuates the emergency or auxiliary heat is really a term that I prefer to use to describe it. So once again, there's our control board. We'll investigate that a little bit more completely as we move along through things. This little smaller board down here is actually the fan control side of things, and so it's got a couple of spade terminals, actually 3 spade terminals there, where we can indicate whether we want low, medium, or high CFM air delivery, that is, and so on. So what we see down in the bottom, or maybe don't see on the screen all that much, is all the controls running out to the fan. We're not going to get into that too heavily here with this unit, but nonetheless, the fan is controlled under various circumstances and generates more or less what would be considered to be the appropriate speed. So what we have along here is the terminal strip, and you'll note that it's on the bottom, it's wired in with various different colors of wire. We'll look at those a little bit more completely in a moment, but those are the lines that would arrive hooked up with the heat pump as it comes to you and is delivered, or has been delivered, whatever the case may be. On the top, as per the identifier label here, are the various different spots that we can connect lines from the thermostat, various things like that. We don't have too many connected. All we're talking about here now is supplying power to the Y or the Y1 terminal in this particular case here. So what we're having is a feed coming off, ultimately the 24 volts. It's coming up, and this is a a switch that would simulate the call for heating, let's say, on the thermostat. And so that then delivers power to the Y terminal, which ultimately is going to end up triggering a relay over here on the high voltage side. But let's leave that for just a second. As we were talking about in the refrigeration system, you'll see a few different, or at least you may recall, there were a few different safety factors there. And those being the high pressure refrigerant and low pressure refrigerant. And as the name implies, what's going to happen there is that if the refrigerant pressure gets too high, it's going to shut the system down before it does any damage, and similarly if it gets too low. Now the way we've got it set up here is that the high pressure shutoff there, which would be dialed into the refrigeration system, okay? So the refrigeration system would, or at least this would hook up to the refrigeration system right here. That would supply pressure, and as mentioned, if the pressure gets up too high, it will trigger that particular little safety shutoff switch. We'll do kind of manually in just a second, and ultimately you'll shut the system down. Similarly, these two are low pressure shutouts. One would be based on the idea of open loop, and one on the idea of closed loop. In an open loop application, we would go to this point here and we would tie a union in from the valve that is operative with the open loop style of system, and that would switch the different low pressure shutout that it would see. As it is right now, it's with just the cap on this union spot. It is operating in the closed loop mode. Now, of course, or maybe not so of course, the scenario here is that because these are not tied into a refrigerant line, they would actually be seeing low pressure. And so as it stands, unless we simulated a closed circuit there, it'll actually be tripping on low pressure. Okay, so let's play around with those switches just a little bit while we do that, and see exactly what happens. And there's a real logical meaning for this, or reason for this, that we'll explore just in a second as we go through. So let's take this switch here and trip it, and that was a simulated high pressure trip out. And pardon me, I think I've got that wrong. That was a low pressure trip out. And so there are a couple of things you'll notice there. This brighter red LED over here indicated the compressor action. So that simulates the compressor. And over here on the circuit board, you'll notice that the LED there is blinking twice and then a pause, and then twice and then a pause, and so on, and it repeats that process on and on. So on the board you won't be able to see that, but it is indicated that the double click of that LED on the board does indeed indicate a low pressure situation. And this is where it becomes really a critical point in terms of the whole diagnosis of things, because what will cause low pressure? Well, low pressure would be caused by the refrigerant not expanding. And so let's suppose that we're operative in the heating mode and we're drawing heat out of the ground. Well, the function of the heat, remember, is to evaporate the refrigerant. And so if the refrigerant doesn't evaporate, then we end up with this low pressure scenario. The evaporation, of course, expands the volume of it, and that keeps the pressure up. But if the pressure goes too low, then that would be indicative of a situation where the refrigerant is not expanding. Now, what would cause that? Well, very possibly something like a pump would do it. A pump on the source side in the heating mode, because we're not drawing heat out of the ground. Therefore, we're ending up with the refrigerant, as I said, not evaporating and triggering a low pressure situation. So that's really important that we recognize that, because gosh, many of the problems that we run into have really nothing to do with the actual refrigeration system, other than the fact that this refrigeration system is monitoring those and shutting down. It's a little bit like if we don't feed something, it doesn't get what it needs to operate, and we end up with that issue. So I'm going to turn that back on, break off that scenario with the low pressure shutout scenario, and there again you'll notice that once I did that, it restored the action and it allowed the compressor to be brought back on. We'll look at how that happens again just a little bit more completely in a second. On the other hand, the high pressure trip out, the one in this case here that is mounted up at the top of the board, well, that one's going to trip on high pressure. Well, now what would cause high pressure? That would be a scenario where the refrigerant is not condensing. Remember, the phase change is critical with the operation of the refrigeration system. And so we would look toward the condenser. So again, if we reflect on the idea of it being in heating mode, and let's suppose we're dealing with a liquid to air style of heat pump, if the fan weren't operating, or if the filter were plugged and the air wasn't able to move through the fan coil structure there, that would mean that the heat isn't being drawn off the refrigerant, isn't carrying it through the condensation phase, and the pressure would stay high. So if we do that, if we simulate that scenario, we end up with, again, the system shutting down, but now hopefully you can see on the video the LED down here, and it's no longer blinking with a blink, blink, pause, blink, blink, pause. Now it's a single blink, then a pause, and a single blink and a pause. So those particular things are really important, because that indicates to us whether we're talking high pressure or low pressure